All right, let's get right into it. We all put in the work to build these incredible cross-platform apps, right? But the real challenge is making them feel, well, truly native. Snappy, responsive, you know the drill. So today, we're going to break down exactly how you can hunt down those pesky bottlenecks and roll out the fixes that'll get your Android apps running with that amazing native class speed.
Ah, yes, the million-dollar question. It's the one that probably keeps you up at night. You've poured your heart into a fantastic app, but then the reports start coming in about that dreaded, infuriating freeze. It's gotta be one of the most common problems we face as developers, so let's get to the bottom of it, shall we?
You know, before you can find the cure, you have to really understand the symptom. And I like to call this one the phantom freeze. It's that moment where the UI just locks up solid. No response to taps, no nothing. It's the most obvious sign that something's gone seriously wrong under the hood, and it's our first big clue on the path to a solution.
Oh man, we have all been there. Your app is in the middle of some complex calculation, maybe downloading a file, and then, poof, it's gone. The UI is just a frozen picture. That is the classic sign that your performance is taking a nosedive. And you know what that leads to? A one-way ticket to a bad user review. So, what's the game plan? How do we fix this thing? Well, we start by diagnosing the root cause, because this isn't just some random bug that pops up. No, it's a very specific problem, with a name, and it almost always leads back to one single critical place in your app's architecture. And here it is. This is our culprit, the infamous ANR, which stands for Application Not Responding. This is Android's official name for when the main UI thread, the one responsible for literally everything the user sees and touches, gets blocked for more than 5 seconds. This is the technical monster that we need to slay.
And that quote, it absolutely hits the nail on the head. Every single ANR investigation begins, and frankly ends, with the main thread. When that thread gets bogged down, everything the user is trying to do comes to a grinding halt. So the real question is, what's blocking it? Okay, so this slide is basically your go-to diagnostic checklist. An ANR is almost always caused by one of these three things. Number one, you're doing heavy lifting, like network calls or database queries, right on the main thread. Big no-no. Two, the main thread is trying to grab a resource that some other thread is hogging, creating a deadlock. Or three, the main thread is just stuck waiting for some other slow process to finish. If you ask these three questions, you'll find the source of the freeze. I guarantee it.
All right, diagnosis is done. Now it's time for the treatment. And our first battleground is the user interface itself, specifically how we build and render it. You'd be surprised how often an inefficient layout is the silent killer of performance.
I love this analogy. It's perfect. Think about it. We often reach for nested layouts because they feel so logical, just like stacking Lego blocks one inside the other. But what's really happening is that every single level of nesting adds another whole layer of measurement and drawing calculations for the system. A really deep hierarchy of views will absolutely destroy your rendering performance. The key then is to aim for flatter, wider layouts whenever you can.
So what this all comes down to is being smart about your UI updates. Here are 2 super practical tips. When you're populating a huge list, say a list box in Delphi, always wrap your loop with begin update and end update. This basically tells the control, hey, hold on, don't repaint yourself after every single item I add. Just wait and do it all at once at the very end. It is such a simple change, but the impact is massive.
Okay, but what if your UI is nice and flat and it's still slow, especially when you're scrolling through a bunch of images? Well, that constant loading and rendering can totally overwhelm the main thread. And this is where a high-performance 2D graphics library like Skia can be a lifesaver. It's an open-source engine, the same one Google Chrome and Android itself use to draw graphics at incredible speed.
And, the results really do speak for themselves. This chart shows it all. If you use standard image controls in a list that's updating quickly, you can see the frame rate just tanks to a choppy 26 frames per second. But, and this is the cool part, by swapping those out with custom controls backed by Skia, the performance shoots right back up to a buttery smooth 60 FPS. The difference is just, it's night and day.
Now let's move on to our next area of treatment, memory management. I mean, a fast UI is totally useless if your app just crashes because it ran out of memory, right? And this is absolutely critical on model devices where every byte of RAM is precious.
And listen up, because this is a really big deal that's happening right now. There's a change coming in Android 15 that's going to force all of us to rethink our memory strategy. Google is fundamentally changing the most basic unit of how memory is managed.
For years and years, Android has managed memory in these little chunks, these 4 kilobyte pages. That's been the standard forever.
Well, with Android 15 on devices with enough RAM, that number is quadrupling to 16 kilobyte pages. Now, this shift lets the system manage memory more efficiently and even launch apps faster. But, and it's a big but, it comes with a major catch for us developers.
And here is the critical takeaway. If your app uses any native libraries, those precompiled .so files, and they weren't built with this new 16 KB alignment in mind, they will simply fail to load. Your app will crash instantly on startup. So this is a huge call to action. You've got to check and update all your dependencies.
So, besides that urgent update, here are a couple of timeless memory tips. For caching images, don't just throw them in a simple list. Use a class like LRU cache. Why? Because it lets you set a memory limit in bytes, not just a number of items. Think about it. 100 tiny thumbnail icons use way less memory than 100 giant photos. And of course, never ever load a full-res image just to show it as a tiny thumbnail. Scale it down first to avoid those awful out-of-memory errors.
So, we've optimized our UI, we've mastered our memory. Honestly, that's going to solve the vast majority of performance problems out there. But for those really demanding tasks, I'm talking real-time audio processing, complex game physics, sometimes you need to go deeper. So let's talk about some advanced low-level techniques to really unleash true native speed.
And it all starts right here, in your development environment. Your IDE isn't just a place to write code, it's your command center. It's packed with tools for profiling, debugging, and compiling for different targets. This is ground zero for configuring the advanced stuff we're about to get into.
Okay, to get to that absolute pinnacle of performance, sometimes you've got to write code that talks directly to the hardware. That's where the Android NDK, the native development kit, comes into play. It lets you write code in C++, which can then tap into special CPU instructions. And the most powerful of these is called SIMD. It basically lets the processor perform the same operation on multiple pieces of data all at once. For things like image processing or physics calculations, this is a total game changer.
Phew, we've covered a lot of technical ground. But achieving great performance isn't just about applying a few tricks here and there. It's really about adopting a certain mindset, a way of thinking about how you write your code from the moment you type the first line. I absolutely love this quote, because it just flips a common misconception right on its head. We tend to think that optimizing code means making it messy and unreadable, right? But true optimization, choosing the right algorithms, building efficient data structures, that often leads to code that is simpler, cleaner, and more elegant. Good performance is really just a symptom of good design.
And that leaves us with one final thought to chew on. As our phones get ridiculously fast and memory sizes keep growing, it's really tempting to think that maybe optimization doesn't matter as much anymore. But, as we just saw with that Android 15 update, the platform itself is always changing under our feet. So, is peak performance a destination you finally arrive at, or is it more of a continuous journey of adaptation and refinement? Something to think about.